So there is a resistor and a capacitor. So this is 220 divided by 178 and 8 into 10 power minus 10 coulomb. Both R1 and R2 are 20 centimeter. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. Today's class, we will work out the next model question paper, model question paper 4. Hope you have gone through the previous papers and you have come prepared for today's session. The first problem, a very important one. The problem says A, B, C, D is a square of side 1 meter. Very important. It is a square of side 1 meter. And point charges 2 into 10 power minus 10 coulomb and 8 into 10 power minus 10 coulomb are placed at the corners A, B and C. So we have charges 2 into 10 power minus 10, 4 into 10 power minus 10 coulomb and plus 8 into 10 power minus 10 coulomb placed at the corners A, B and C. I have to calculate the amount of work done in transferring a charge of 10 microcoulomb from D to the point of intersection of the two diagonals. So according to the problem, there is a square. So a square, what he calls A, B, C, D. Now the charge placed at A is 2 into 10 power minus 10 coulomb. Charge placed at B is minus 4 into 10 power minus 10 coulomb. And the charge placed at C is 8 into 10 power minus 10 coulomb. So these are the charges placed respectively at the points A, B and C. Now, if you observe, the square has side 1 meter. Now I draw two diagonals. Assume O is the center or the point of intersection of the two diagonals. I have to calculate the work done to transfer a charge. Suppose there is a charge of 10 microcoulomb at D. How much of work has to be done to move it to this point O? Which means now I want this distance OD. First I have to calculate the distance OD. How do I do that? Now, it is very simple. So I consider the triangle BDC. So BD square, the hypotenuse BD square is CD square plus BC square. This is by using our Pythagoras theorem, or this is 1 square plus 1 square, which is 2. So BD is root 2. If BD is root 2, OD is half of that. Therefore, OA equals OB equals OC equals OD is 1 by root 2. Half of the hypotenuse. To begin with, I will calculate the potential at this point O. How do I calculate? Potential at O due to the charge at A. Potential at O due to the charge at B. Potential at O due to the charge at C. Do I consider the charge at D? No. Why? It is moved to the point O. Therefore, VO, the expression for potential is 1 by 4 pi epsilon naught charge by distance. So 1 by 4 pi epsilon naught is common. Charge at A is QA divided by OA, the distance O to A, plus QB O to B plus QC O to C. So this is the potential at the point O. So VO equals 9 into 10 power 9. How much is the charge at A? It is 2 into 10 power minus 10 into 10 power minus 10 divided by 1 by root 2 minus 4 into 10 power minus 10 divided by 1 by root 2 plus the charge at C, 8 into 10 power minus 10 divided by 1 by root 2. And when I simplify this, V0 turns out to be 7.63 volts. So this simplification, as I always say, is left to you all. So V0 is 7.63 volts. My next task is to calculate the potential at the point D. So the potential at the point D is again 1 by 4 pi epsilon naught QA divided by AD plus QB divided by BD plus QC divided by CD, which is 9 into 10 power 9. Again, QA is 2 into 10 power minus 10 by AD is 1. So this is minus 4 into 10 power minus 10. Now if you observe, BD is the hypotenuse. So we have to be very careful in substitution. Hypotenuse is root 2. So this is root 2 plus QC again minus 10. So on simplification, VD turns out to be 6.45 volts. So I have calculated VD, which is 6.45 volts. Now, therefore, the potential difference between the 2 points VO minus VD, which is 1.18 volts. So on calculating the potential difference, how do I calculate the work? We know V is W by Q. So W is V into Q. V is 1.18, 10 power minus 6. So on simplification, this is 11.8 into 10 power minus 6 joules. So step by step, it appears to be tedious, but very simple. I can arrive at the answer. The next problem. Two cells, A and B. There are two cells, A and B, connected in series, such that each has an EMF of 1.5 volts. So EMF of each cell is 1.5 volts. The internal resistance of A and B are 0.5 ohms and 2.5 ohms respectively. The combination is connected across a resistance of 2.25 ohms. Calculate current in the circuit, potential difference across the terminals of each cell. Which means first, I will calculate EMF of the battery E equals EMF of each cell is 1.5. ಎರಡು ಸೆಲ್ಗಳಿದೆ. So total EMF becomes 1.5 plus 1.5, which is 3 volts. So the EMF of the battery turns out to be 3 volts. Similarly, internal resistance of the battery, small r equals internal resistance of the first cell is 0.5 ohm. Internal resistance of the second cell 0.25 ohm. This is 0.5 plus 0.25. So which turns out to be 0.75 ohms. So this is the internal resistance of the battery. And you observe there is an external resistance also. So total resistance R is equal to 0.75 plus 2.25, which is 3 ohms. So I've got the EMF of the battery, internal resistance of the battery, and total resistance of the system. First, I have to calculate the current flowing through the circuit, which is E divided by R. So this is 3 by 3, which is 1 ampere. Next, I have to calculate the potential difference across the cells. So we have VA is E minus I RA. So which is now EMF of the first cell, only first cell, 1.5 minus 1 into 0.5. So the answer turns out to be 1 volt. Similarly, as an assignment, calculate VB, which is the EMF of the second cell. The next one, students, the problem says 80 ohm resistor and 20 micro capacitor, 20 ohm resistor and 20 microfarad capacitor are connected with an AC source of 220 volts, 50 hertz. Calculate the potential difference across each one of them. So there is a resistor and a capacitor connected in series. The moment you see capacitor, first we will calculate the capacitive reactance. So capacitive reactance XC, which is 1 by 2 pi FC. So on substitution, 1 by 2 into 3.14. So frequency is given to be 50 hertz. So this is 50 into 20 into 10 power minus 6. So this turns out to be 159 ohms. So as the first part of the calculation, I have got the capacitive reactance, which is 159 ohms. The moment you calculate XC, the next one is to calculate impedance. So Z equals R square plus XC whole square root, which is 80 square plus 159 whole square. Kindly see that you proceed on with the simplification. So the impedance turns out to be 178 ohms. So XC is done, Z is done. Now I'll calculate the current flowing through the circuit, IRMS, which is VRMS by Z. All these relations, explicit number of times I have done in the concept class, in the sessions. So you have to be thorough with this. So this is 220 divided by 178. So this is again 1.25 amperes. Now with whatever solution I have got, I will first calculate the potential across the resistor VR, which is I RMS into R. Basic application of Ohm's law. Substitute Madi. Work a bit, you will get that satisfaction. Potential difference across the capacitor. Again, IRMS into XC. See, step by step, one quantity by another, easily we are arriving at the solution. The next one. A double convex lens made of glass of refractive index 1.56. So refractive index of glass 1.56 has both radii of curvature of magnitude 20 centimeter. If an object is placed at a distance of 10 centimeter from this lens, find the position of the image formed. Radius of curvature kottidare. Refractive index is given. I will first calculate the focal length. So the focal length is, so by lens maker's formula, 1 by F is N minus 1, 1 by R1, 1 by R2. So this is 1 by F. Refractive index is 1.5 minus 1. both R1 and R2 are 20 centimeter, which is 0.2 meter. 1 by F is equal to 0.1, 0.1 divided by 0.56. So, which is equal to, on simplification, so this is F, which turns out to be 0.17 meter. Now, with this, I have to find the nature and position of the image, for which I use the lens formula. 1 by V is 1 by F. So this is 1 by 0.1 plus 1 by V, 0.17. On calculation, V is minus 0.227 meters. So very clearly, because of the negative sign, it is virtual in nature. Going to the last problem, which is on nuclear fission. This is a complete assignment for y'all. I worked umpty number of problems on such cases. Go back to the session, try to solve. The next class, I come up with few more problems on the model question paper. Until then, have a nice time. Thank you.